And hello everyone, welcome back to another Love2D tutorial. So if you haven't seen my previous tutorial where we get started with creating the game, I highly recommend you do, because we did do some setup there. You don't have to watch it, but I do recommend you do, because we are going to use that setup here. So first of all, this right here, this doesn't need to be here. You can actually remove that. It will run perfectly fine because by default Love will import it. But I'm still going to keep this here just to get all of those errors away and whatnot. So yeah, that's up to you before we continue, right? Okay, so in this tutorial we'll be creating the enemy. The enemy that's going to kind of run after us and whatnot. So first I would like to give our game another property. Difficulty. And difficulty is going to be set to 1. Now, the higher the difficulty, the more difficult the game should be. As simple as that. Because the speed of the enemies will be kind of dependent on the difficulty as well. And then we want to create a table called enemies. Now, this table isn't going to be used too much in this tutorial because we're only going to have one enemy. But once we get deeper into it, this table will be containing all our enemies. So all our enemies are going to go in here. We want to basically create our enemy object. Now we could do it in here, but this file is already going to be very big by the end of this tutorial. So we want to create a new file. So right here, we can right click, new file, and say enemy.lua. I'm going to give it a capital case E in its name to signify that this is an object. It's completely optional, it's just how I like to do things. If you have seen my tutorial on OOP, you will probably know there's multiple ways you can do OOP in Lua. And the first way is by using a table, the second way is by using a function and a table. And there are more ways, but I don't like covering the others because they're kind of difficult to understand, in my opinion. So in this case, I'm going to use functions and tables because I find those to be the most easiest to use. So first, we want to import love. So local love is equal to require love. Cool. And we don't need a semicolon. We're going to create a function and we're going to call it enemy. And this is going to be our object for enemy. Now, at the end of this function, we want to say return enemy. And this will basically export this enemy once we import it here. So this will be exported, this function right here. It's just so this massive function won't have to be found or used or whatnot in here. We don't have to see that massive function in here because it will be stored here. So let's start with very basics. We're going to return. And whatever is inside of this right here, this table, is going to be what's returned to us. So first we want to set the level to 1 by default. The radius, I'm going to make that equal to 20. Then the x is going to be equal to, and this is going to be enemy position for in case you didn't know. I'm going to make it, let's say, -10. And the y is going to be equal to -50. So basically this is where the enemy's start position will be. We want it to be off the screen and we're going to randomize where they actually come from later. But currently we want it off the screen because it should kind of just pop into the screen as the level goes on. So more enemies will pop into the screen. Cool. So these are the first few things we'll use. Next up, we need to basically create something to draw the enemy and something to move the enemy. Let's first try and move the enemy, because that's probably going to be the most difficult part here, is just moving the enemy. And that's going to be a function inside of this table. So it's a function inside of the table. And it's going to take in 3 items. Self, yet again, in my OOP tutorial, because it's going to take in itself. We also want to get the player, player X and the player Y. You could pass in the entire player in here, But I feel like that would just be kind of a waste of memory on the end of the day, because you're going to pass in an entire object when you can just pass in two values. So I do recommend passing in these two specifically, just the x and the y. Cool. Now basically we want to make the enemy move to the player. That's all we want to do. Very simple. We just want the enemy to go towards the player. So it will just be basic if statements. So if player at index x, or at x position, minus self.x, and this self is referencing this x right here, so where the enemy currently is. So if this value is more than 0, then self.x is equal to self.x plus self.level. So what we are doing here is basically if the player x minus self.x, if that is more than 0, and we're minusing here because remember x starts basically at this point right here. Alright, so future Steve here, and I realized this wasn't a very great explanation. So let me actually explain it better. Let me just move this to number 3. So here we have basically our example. It's saying if the player at position, the x position of the player, minus the x position of the enemy. So let's quickly go here and just draw it out. Let's say the enemy is a red square. So this is the enemy. Or actually, let's make it a circle, otherwise things might get confusing. Okay, so the enemy is a red circle. And the player is a blue circle. Just draw a nice circle here. There we go. Now, here we're saying if the player at position x, okay, so the x position of the player would be there at the center. That would be the x position from here all the way up until there. That's the x. Because remember, x goes from side to side. That's x. While y goes up and down. So this would be y. So just remember that. So this is the x, right? Now we go here. If the player x, and yeah, so if the player x minus self.x, and self.x would be the x of the enemy. So this right here, this would be the enemy x. That's self.x. So this is the enemy, self.x right there. Now if we go here, we see if it is more than 0. Okay, so let's put this in a mathematical perspective. So let's say this right here is 63. The x position of the player is at position 63. And the x position of the enemy is at position 10. Now we are saying player at position x, okay, so it's 63. Whoa, let me just 63, right? Minus self.x, okay, so it's minus 10, because remember self.x is the enemy. So it's 63 minus 10, right? And that will give us 53. So the position between this point and this point is 53. That's basically what's being said here. And then we're saying if it is more than 0, and we know 53 is more than 0, then we're saying self.x. So this would be the player x, or the enemy x, not the player. The enemy x is self.x. So we're saying self.x is equal to itself. Okay, so self.x, which is 10. Let's make this red because we're talking about the enemy. So it's 10 because we're saying self.x. Okay, so it's going to be itself, so that is self.x, plus its level, so plus 1. So we are saying self.x becomes itself plus 1. So now self.x will be 11, because it will now be one step closer to the enemy. Meaning this right here will minus with 1, because 63 minus 11, and remember we got 11 with that quick equation, so that would be 11. So 63 minus 11 is equal to 52. So that will basically close the gap between the enemy and the player. This might be a little bit confusing to work with, like a lot of the math might be in game development. But don't get discouraged, because the more you work with it, the more you'll understand it. So yeah, back to the video. Now we also want to do the other side of x, so let's say the enemy is to the right of the player. So else if, and then player minus self.x is less than 0. So basically, if the player x minus self.x, because remember x becomes more the more you move right. So if the enemy is more right than the player, then this will be a negative value. This will return something negative. So basically, let's say this right here, that's the enemy, and this right here, oh yeah, no, not yellow, we can't see that. Okay, and this right there, that's the player. Now let's say on x, so x here would be equal to 2, and x here would be equal to 5. And remember, this is the enemy, that's why he's red, he is bad, he's the enemy, bad. So let's just full screen this. So here we're saying if the player minus self.x is less than 0. So if the player, so 2 minus self.x, and remember this is the enemy, so minus 5 is less than 0, then do something. Now 2 minus 5 is negative 3. So this will return true. So if the enemy is to the right of the player, it will return true. And with the top one, if the enemy was to the left of the player, it would return true. If the enemy, it would be the same thing, just other way around. Now here you can just say self.x is equal to self.x minus self.level, because we want to decrease the x position of the enemy. If you're having trouble kind of wrapping your head around this, don't worry, the first time it can be a bit difficult. I had the same problem when I first thought of this, like, ugh, wow, my brain can't wrap around this math. But don't worry, it gets easier. And it's going to be the same thing, but for y. So if y, let me just change all of these to y. So if player y minus self.y is more than 0, then self.y becomes the same but plus. It's the same thing, now it's just y. Because if I were to open up drawing, then basically remember y goes down. That's how y goes. So this is the player, and this is the enemy. Now let's quickly go check here. So if the player y minus the enemy y is less than 0, so the enemy y, let's say, is equal to 10. Because remember, goes down, so this would be 0, and this would be something like 20 or something. And here, the y would be equal to, let's say, 5. Now, here we're checking if the player y minus self.y is less than 0. So if 5 minus 10 is less than 0, and those two minus will be negative 5, right? And that is less than 0. Then we're saying, wrong window, self.y becomes itself minus level, so it will decrease. So now we're saying, okay, move this upwards. So now the y will become 9 because we're moving it upwards. And this is going to run with every update. So it's going to move the enemy closer to the player with every update. So yeah, let's continue to the next part then. Now we want to be able to draw the enemy. So that was going to be another function called draw. It's going to be function taken self, doesn't have to take in anything else. And here we first want to set the color. Love.D love.graphics.set color. This is basically just going to set the color of the thing we're going to draw. Now I'm going to choose a very random number in order to figure this out. So I'm just going to say 1, 0.5, and 0.7. Just a random number that popped up into my head. Remember, you could have also gone like 255 divided by 255. And same here, you could have just gone, what's the half of 255? Anyways, the half of 255 divided by 255. So you could have done that as well, but I preferred not to in this case. And then we're going to draw a circle, but you can make the enemy a different shape than a circle. I just find it easier to do it as a circle. So love.graphics.circle, and we're going to fill this circle. We're going to put it at position self.x, self.y, and it's make the size of self.radius. So we're going to draw a circle at it's the x index, the y index, and then we're going to give it this size right there. And we set all of that up here. And then we can say love.graphics.set color. So we're going to reset the color back to white, because that's going to be our default background color. You don't have to set it here, but I prefer setting it here than having to set it here in this draw function over and over and over. It also just prevents a bunch of bugs that could possibly occur. Okay, so that's the most basic version. We'll later on throw in letting jump in from random size, but I think for now that should be fine. So this is the enemy. Now here we have our enemy object, and now we can insert our very first enemy. So here in load, we want to insert our first enemy. Table.insert, and it's just a normal insert method. And I'm going to insert it into the enemies table right there. And we need to import enemy, now that I think about it. So local enemy. And you don't have to give it the same name. I just like using this name. And we're going to say enemy. And it should be capital E. That just means basically import enemy from this file right here. That's what we're saying right here. Cool. Now that we have that, we can go here and we can say at index 1, insert our first enemy. And it should not have a capital E because we gave it a lowercase e as a name. Or we should have. There we go. Lowercase e, not capital E. Okay, but you could give it a capital case E name. I just preferred going lowercase. Cool. Now that will insert our first enemy. Now here in update, before we can actually try and use this enemy, we need to basically for I, and yeah, let's just go like that. For I equals 1, and let's also remove all of that, until the number of enemies, and then do. So basically, for every enemy inside of this enemies table, currently we only have 1, but later we'll have more. We want to go enemies, or enemy, or yeah, enemies actually, and then add that index, so index I, colon move. Take note, I'm using a colon here and not a dot. And then here we can just pass in the player dot x and the player dot y. Why am I passing these in? Because here in move we're taking player x and player y. We do not have to pass in self because self gets passed in for us. Cool, so for every enemy, do this. You can also create an update function instead that will, instead of just moving it, it will do all of the updating for the enemy. That could also be something you can rather implement instead of move. But this game is so basic, I'm just going to have a move function and not an update. Cool, now we need to draw the enemy. Let's go here into if the game state is running, right? Then we can go and above the player, because we kind of want the player to overlap with the enemy, or you could do this below, it doesn't really matter that much. And actually I'm just going to copy this because it's going to be the same code, just a different command. So boom, and here I'm just going to say draw. So this will draw every enemy inside of the table. Okay, so let's try and run this and see what we get. Love dot. Let's see. And you know what? We're not getting anything. It's because currently we're in the menu state, and everything just gets drawn if the state is not the menu. So yeah, let's go there and just go false. And in here, we can just say running is true. There we go. Now it should work. As you can see, there the enemy comes to get us. But currently nothing happens. So the enemy just stops once it gets on top of us. But it should later on like stop the game if the enemy touches us. But you'll also notice the enemy always comes from the same side. And that's very boring, because we want the enemies to actually come from different sides to make the game more interesting. So to do that, we can just implement a little bit of math. And this math will basically make the enemy come from different sides. Now, here at the top, I'm going to declare 4 variables. Local dice, local x and y. And take note, these have underscores. You don't have to give them names with underscores. I just find it much easier to work with them if they have that. And also local and an underscore radius. Cool. These two are not going to have any values associated with them at the moment. Radius will make 20 as a default, but you can later on then modify this radius to give you more interesting sizes. So let's say you want different size enemies. That could be kind of neat. Now this radius here, I'm going to paste it here. This x here, I'm going to paste it here because it's going to be modified. And this y here, I'm going to paste it here. So these are all going to be modified except for radius. So these are all going to be modified, and these two will now be set here. And we're doing this because we want the self to work when we want these. Because this is not part of the table. It's part of the function, but it's not part of the table that's being returned to us. But it is part of the function. So this one won't be returned to us. We won't be able to access these values. But we will be able to access any values in here. It's something you have to wrap your head around because it can be a little confusing. Okay, and this dice will basically determine from which side will the enemy appear. From this side, from this side, from this side, or from this side. So I'm going to make this a math.random. And we're going to make it 1 and 4. And before we forget, in the main.lua file, not in the enemy, but in the main.lua file, we want to just math.randomSeed. And we want to just give it os.time. Now, what we are doing here is we're basically saying every second change the seed we're going to get. So whenever the user boots up the game, their random numbers will be more random. Because if we don't add this, then the enemies will always start from the same place. And we don't want that. Because currently, as you might have seen in my random video, the random numbers don't really change. They kind of stay the same. Unless we seed them. So, unless we seed them. If you don't understand that yet, I do recommend you go watch my tutorial on it. I do have an entire crash course on it after all. Cool. Now we need to basically give the dice functionality. So we can say if dice is equal to 1, then underscore x is equal to math.random. So we're going to give it a random position on the x-axis. So anywhere random here. So there we go. Math.random. And then underscore radius, because we wanted to start at minimum at the radius. So the enemy will always be hidden, no matter where it is on the x-axis. And in love.graphics.getWidth. And this will just throw in the width. So it will give us basically a random number between the radius, so 20, and the width that's given to the window. And then we want to say y, we can actually just do it underneath, y is equal to minus, so negative, underscore radius times 4. So if the dice is 1, and this should be underscore y, so if the dice is 1, x can be anywhere on top of this right here, anywhere. But y specifically will be minus the radius. So remember, it's going to basically be here. So y0 is here. So y minus the radius would go up. So minus the radius will basically mean hide the entire ball, hide the entire enemy. And we times it by 4. So it's going to be basically being hidden 4 times itself. This will also give it a little bit of a time you have to wait once the new level starts before it actually starts jumping in. So it doesn't just go into the screen immediately. You'll kind of understand it once we actually use this. So now we can just say else, and I'm just going to copy this right here. Alright, a little disturbance, I can't remember where it was, but okay. Yeah, I believe it was just like this, and we go boom. Okay, now else if the dice is equal to 2, it's going to basically be the same thing. But I'm just going to copy these else ifs, because we're going to have kind of a lot of them. Except for the last one. The last one will just be else. And in this one we can make 3. And in the else would be if it's not 1, 2, or 3, then just give it this one by default. Okay. So with the second one, it's going to be a little bit different. It's going to basically be swapped. So x will contain this. And y will contain this. And then here we can, instead of say get width, we can say get height. Now, why is this like this? Why did we swap it around here? Well, if the dice is 2, we're saying, okay, x should be here, but it should be minus its own width. So basically it should hide itself times 4. So it's going to go to the side here 4 times itself, its own width. And then with y, we're saying, okay, find any place from this part right here, right? And just anywhere towards the height. You don't necessarily have to specify this radius here. You could make this 0, because remember, it's just going to come in from a random side anyways. But basically, it's going to be able to come in from anywhere on this side right here. So if the dice is 2, anywhere here. If the dice is 1, anywhere here from the top. If the dice is 3, however, then we're going to do everything the same. But this one right here, this y, we're going to say love.graphics.getHeight plus, and then we're going to say radius times 4. Whoa, radius times 4. And no minus. So why are we saying this here? Well, basically we're saying, okay, if the dice is 3, x can be anywhere from this right here. And then we're saying, okay, the y should be the height plus itself times 4. So anywhere from below here. So now it's not anywhere from the top, but anywhere from the bottom, like from here. That's what we did here. We basically set the y to the bottom of the screen. And then here it will be basically the same as with if dice were 2. So we can do like that. But now the difference is, and remember to remove this minus symbol right there. X here, we can just go and, well, no. We just go and do this. And we can say love.graphics.getWidth plus. And now what we're saying is, okay, it can come anywhere from this side right here. So now it can come, the ball, the enemy can come from anywhere inside of this window here. Not this window, but the game window itself. So it can either come from here, the top, which we did first, or it can come from the side, which we did second, or from the bottom, which we did third, or from this side right here, from the right side, which we did last. And now these x and y values, as its default values that ball first gets, comes from here. And this will be different for every ball. That's the nice part, because every time we create a ball, it's going to execute all of this. And then it's going to return this to us. But this x and y would have changed. And if you want, you can also change the radius. So yeah. Now if we were to run the game, it comes from the part down here. Okay, let's run it again and see it happening again. Oh. Attempt to perform algorithm get field a function value. So this is enemy 18. Let's see here. Ah, there we go. That should have those little bracket things there. Okay, let's see. And it starts from this side now. Okay, one more time just to make sure we have everything. It starts from the top. So that's the nice thing. Every time you start the game, it starts from a different angle, which is pretty neat. And I believe that's all we need to do for the enemy. So yeah, thank you for watching. I hope you all enjoyed, and I do hope to see you all again in the next Love2D tutorial. We'll be continuing on building our game.